Okay, I think we're getting a good number of participants. We will get started. So welcome to the Helix webinar series. Today's session is on best practices for service management. So this is part 2. Hopefully many of you joined part 1. If you didn't, don't worry. I will be sharing out that recording when you get your thank you email so you can catch up. Today joining me is Nikhil, Alicia and Kashita. They will do their formal introductions when we get started on the presentation and demo. Before we do that, just a reminder, there is the Q&A section of Zoom. If you have any questions during the demo and the slides, please put your questions in there. We will have time, roughly around 15 to 20 minutes at the end, where we will take your live questions if you want to speak with us, or you can put them into the Q&A. So I'm now going to hand over to Nikhil, who will get us started and do the introduction to the session today. Over to you, Nikhil.
Thank you, Sam. Good morning, good afternoon, good evening to our participants, wherever you're joining us from all over the world. I'm Nikhil Deshpande. I am a product manager for Helix Dashboards, and I'm excited to be back presenting one more webinar to our customers and partners. Over the past year or so, we have seen tremendous interest in understanding Helix Dashboards. One is, of course, the transition from smart reporting to dashboards that most customers have completed by now. Several others are in that transition. But regardless, from what we have observed over the past several months, we've realized that many customers want BMC to advise them on what are the best practices of using dashboards. And that's precisely why we conceptualized this webinar series on what are the best practices of developing dashboards for service management products. The goal being that we need to enable our customers to get value out of Helix dashboards. Broadly, there are 3 areas that we need to understand. One is how to leverage the various capabilities of the reporting tool, Helix Dashboards, to design optimal dashboards. Ultimately, the report designer or developer or data analyst must develop or design the report in a way that's optimal. So what are those tips and tricks? What do you need to be familiar with? What features about Helix dashboards specifically do you need to know so that you can design dashboards that run optimal in production environments? So this was something that we covered in part 1 of the webinar, which we did 2 weeks ago. Hopefully, many of you would have attended that webinar. The second one today will focus on the next 2 items, which is about writing efficient database queries. If you've worked on databases, you know the importance of writing optimal queries, yet we find that a number of our customers still look for some advice on how to do that. So we have collected all the feedback that collectively within BMC about from our product development teams, support teams, all the expertise that we have gathered on this, supporting many of you over the past year. What are the best practices of writing efficient SQL queries? So that's what today's webinar will focus on. We'll also focus on a third item today, which is for your database admins or your ITSM admins to be familiar with. What do you need to do to optimize database performance? This is not something that every report developer would do, but as an admin, you need to be familiar with these things so that you can do it on behalf of your company. So today's webinar is going to be focused on queries for the report developer persona as well as for the admin persona. Next slide, please. So this is the webinar series. We did these webinars for the Asia Pacific time zone. The first one, part 1 on 11th February, part 2 on the 25th. And can we go to the next slide, please? We did part 1 for EMEA and Americas 2 weeks back. And today we are doing the second part of this series. If you missed the first one, we have already shared a recording of the first part of this webinar series. Next slide, please. With that, I'm now going to hand off to Alicia, who will cover the first part of today's webinar. Over to you, Alicia.
Thank you, Nikki. Hello, and welcome to the second part of this webinar series focused on Helix Dashboards best practices for service management. My name is Alicia Beltran. I'm a senior support analyst in BMC. Today, we will talk about the streamlined query design, how to write optimal queries, how to troubleshoot timeout queries, and finally, we will have a demo with use cases. I will walk you through the first two topics in the agenda, streamlined query design and writing optimal queries. Let's start. Here are the different phases that were reviewed in our previous webinar session. Today, as we mentioned, we will focus on writing optimal queries, but let's do a brief refresh of these stages. Planning refers to defining the objectives of dashboards and choosing key metrics that are relevant to a use case. Effective variable design is when we prevent unnecessary data retrieval. Today, we will go deeper on writing optimal queries, covering the best practices to write optimized queries and reduce query execution time. The phase of optimizing dashboard efficiency covers the key approaches on how to use dashboard features to reduce the dashboard's initial load time and improve the overall performance. And finally, we need to have a phase to test and iterate as changes in dashboard design are made. Okay, so let's start. The first important step is streamlining the query design. This step is required as well-planned and well-structured query design set the foundation for efficient and reliable operations. Before we start writing the query, we need to have a clear idea of what data we need, where is it stored, and how it is related. So it is required to understand the structure and content of AR forms. This helps in defining the criteria and logic of the query, such as the filters, join conditions, aggregations, and calculations. Then we need to focus on retrieving only the required data and columns to keep queries efficient and fast. Also, we need to focus on properly formatting the SQL queries as it enhances readability and simplifies debugging. This can be done by adding meaningful aliases for columns or tables, by using uppercase keywords, breaking queries into multiple lines, and adding comments to improve structure and clarity. It is good to include comments that clarify the different sections of the query and help others and yourself in understanding the query. Okay, I will now move on the best practices of writing optimal queries. Okay, we'll cover several approaches and suggestions. The first one is to avoid using select all or select start and apply select distinct whenever is required. Running queries with select all retrieves all information from the database table, including unnecessary data, which can be time consuming. A better approach is to use select statement with specified columns to fetch only the required information. Also, while select distinct is useful for removing duplicate rows from query results, it can have a significant impact on query performance. This is because the database has to process the entire result set to identify and eliminate duplicates, which can slow down query execution. So it is important to use select distinct only when it is required. Let's move to the next approach. It is always recommended to define appropriate filters and limit the data returned as it improves query performance by reducing the volume of records processed. Filters ensure the data is relevant and focus on the user's needs, such as by selecting a specific time period, group, or company. Also, static values in the where clause helps to optimize query performance. These fixed values simplify query logic and ensure consistent results. Using static values, such as specific statuses or time ranges, enhance query speed and clarity. Use small daytime ranges and default filter values in variables. Limiting daytime ranges in variables helps reduce the amount of data processed and improving query performance. This is important for dashboards that needs to display raw information having multiple columns in the table visualization. Also, setting default filter values in variables ensures consistent query results and reduces the need for users to manually input filter values, improving the overall user experience. Default values also help prevent errors or incorrect data filtering, providing more accurate results by default. The next approach is use where instead of having for filters. Using where instead of having improves query performance by applying conditions before the data is aggregated. The where clause filters data at an earlier stage in the query execution. It reduces the number of rows processed. This is beneficial when filtering raw data rather than aggregated results. On the other hand, having is designed to filter aggregated data after the grouping is performed, which can be less efficient. Therefore, it is recommended to use where whenever there is need to filter unaggregated data and optimize query performance. Applying appropriate filters in subqueries is crucial for improving query performance. By filtering data within the subquery can reduce the volume of information that needs to be passed to the main query. This approach also ensures that the subquery retrieves only the necessary data before performing joins or further operations. In complex queries, effective filtering within subqueries can prevent unnecessary data processing and enhance overall efficiency. Now, joining on primary keys ensures that the relationship between tables is clear and efficient, as primary keys unlikely identify records. This approach minimizes the chance of incorrect joins and ensures that data is accurately matched across tables. Adding relevant conditions in the join clauses further refines the results, limiting the amount of data processed and improving query performance. By applying filters directly in the join conditions, we can reduce the need for additional processing steps, which speeds up the execution. This practice optimizes both the correctness and efficiency of queries, especially when working with large datasets like ASSET or CMDB. Now, minimizing inner join helps to reduce the complexity of queries and can significantly improve performance by limiting the number of rows processed. Inner joins often require matching multiple tables on specific columns, which can lead to slower execution times. Avoiding correlated subqueries is essential because these subqueries reference outer query values for each row. Instead, we can use joins to achieve the same results without the need for subqueries. Optimizing query design by reducing inner joins and avoiding correlated subqueries ensures faster query performance and better resource utilization. The last approach that I will cover is to limit the size of result sets. As mentioned, it's important to only select the necessary columns rather than select all. However, it is also important to limit the number of rows you are returning, not just columns. You can use limit to reduce the number of rows returned. Adding limit at the end of the query prevents you from unknowingly searching and returning thousands of rows of data when you just want to look for a specific set. I will now hand over to Shitija to cover the last topics in the agenda.
Thanks, Alicia. Hey, myself Kshitija Marathi. I'm from Helix Dashboards R&D team. I'm working as a product developer and I'm with BMC since last 10 plus years. Um, so today I'm going to cover more about how to troubleshoot timeout queries. So as you know, Alicia has covered different approaches that how the query should be designed, how optimal queries can be designed so that these timeout issues can be avoided by following certain best practices. So we'll cover the same in the actual use case demos as well. So let's focus on the first point here, which is about ensuring variables are designed with recommended approaches. So as in part one of this webinar series, we have already covered about um, how to design variables, how to choose variable type. Let me quickly recap about the focused areas, which is like, let's say there are enum type of variables and like priority or status, if we go specific with IT service management use case. Then priority or status are enum fields, and you know that these values are going to remain constant and they are not going to change over a period of time. So you can use constant or custom type of a variable um, in your dashboard design so that unnecessary going to the server and getting fetching the data from the transactional table will be avoided, and that way you will be able to get the your dashboard loaded faster. Then the other thing is you can enable the all or null handling related flag, which is the GUID. I'll show it in detail whenever we will look at the demo. And then first of all, you will need to know your data first. So when we look at IT service management modules specifically, then you need to know which is, so let's take example of incident management, then you need to know which is the parent table and how the other child tables like incident is related to um, a task. Then we have HPD association table, then we have CIs which are associated to incident, then we have assignment log, etc. So how these tables are related with each other, that understanding if we have, then um, it is always better. You will you can choose which type of a variable to design. And then let's go to the second part, which is ensure query optimization strategies are in place. So as Alicia already covered about these strategies, how to write optimal queries. Like whenever, if only needed, then use distinct. Otherwise, you can avoid using distinct. Then choose where condition over having, because in where you will be able to filter the data first, but in having, which is at the end of the query, and you will result into so there will be some delay in fetching the data whenever you use having condition unnecessarily. Then use date time filters wherever applicable, because in IT service management applications, the uh, data is growing on day-to-day basis, like incidents change, problem, etc. If we look at, then it is very much needed that we apply date time filters to have the data filtered based on what you need. So if you're looking for quarterly or monthly data, then design your dashboard and filters accordingly. Then Also, we need to look at if we have subqueries, then let's have um, uh, filtered output for that subquery, so that otherwise what happens usually is subquery result, getting the result from subquery, that only takes more time, and that results are passed to the main query, and overall execution of that query gets delayed. So it's very much needed that you apply a filter criteria to subquery as well, based on the requirement. Then apply limit to the query wherever applicable. So yeah, let's look at the third point, which is breaking down the query to identify the problematic area. So when particularly we look at troubleshooting part, then how to start? First, when we look at timeout issues, then the first part is variables, variable design. If the type is correctly selected and it suits your need or not, and how you can, um, I mean, have that variable query gets executed faster. So on that area, we need to check first. And if it looks okay, then you can look for the time picker det range if it is all good, um, and configured correctly. Then then go to the panel query, which is actually giving a timeout. Then break down that query. So for example, that panel query is having subparts into it, like it has 2 or 3 subqueries, and those results are getting passed to the main query. So just split those 2, 3 subqueries into 2, 3 panels separately and execute those panels and get the result. So based on how much time it is required to execute each query, each subquery result, you will understand that out of these 2 or 3 subqueries, which subquery is taking more time. So you can focus on that particular subquery, that what can be the cause that this query is taking time. So you can look for um, adding a filter criteria to that subquery. Then you can look for distinct, removing distinct if it is not needed, etc. That those things you can look at particular subquery once you get that problematic area, and then merge that change into your main query, and you can see the difference in the output. And the fourth one, which I wanted to cover, is add missing indexes. So here, so this is the last step whenever your tuning of query doesn't work and still you are facing the timeout challenges here. Then what to do? Then get that slow running query. So capture API SQL logs and get the database query. Run that database query directly on the database and look at the result. If the result is similar, so for example, your dashboard query is taking 5 minutes, and on direct database as well, it is taking 5 minutes, then you can go ahead and get query explain plan with the help of DBAs. So for SaaS customers, our BMC team will be able to help and get that execution plan. And then they can recommend which indexes need to be applied based on the execution plan or explain plan analysis. And for on-prem customers, I think they will have the database access and they can follow these steps to identify um, the root cause. Let me move on to the next. So how to write these optimal queries. So now we'll look at best practices of writing optimal queries through one of the asset management example, and also we'll look at a few more use cases which are related to incident management um, and troubleshooting of timeout queries. So I'm on to the dashboards UI, and you can see this is the computer CI list dashboard, which I'm showing right now. And here, if you look at, we have two variables which are configured in the dashboard. So let's quickly look at. Okay, so this is dataset ID, which is particularly applicable to asset management, and it is trying to pull the um, different dataset IDs list. So now what we'll do, by default, I'm going to have all selected. So we can enable this all or null handling flag. And with the help of that flag, what happens actually is when you select all, and if you pass that variable, for example, this dataset ID in your panel query, and the all is selected at the top, then if you go ahead and inspect, you will find that GUID, that all is getting replaced with GUID. And so what happens when this query runs on the server side? A server can identify this GUID, and whenever this GUID is there, then that where condition gets removed from the query. Because when you are saying all means you are you have selected the all values and you need all the results. So this filter criteria or where condition will be removed. And with this feature, we are able to reduce the time it requires for execution of query, because we are simplifying and removing the unnecessary where condition with the help of this feature. So as and when your requirement is suitable for uh, this particular null or all handling, then you can enable this feature flag and definitely go ahead and use this. Then the second is about CI status, which is so as I already mentioned, these enum values are always, they are not changing over a period of time or on daily basis. So you can define it as a comma separated values, and that will avoid the unnecessary query execution, and your dashboard gets loaded faster. So let me come back here on the main dashboard. So here you can see the time picker range. So if we look at asset management example, then these CIs are not getting created on, like, it's not a truly transactional data, I would say, if we compare it with incident or change. So applying this time range, if it is not really suitable for your requirement based on if the dashboard is asset or CMDB, most of the cases it's not suitable to apply time picker in some cases. So in that case, you can hide this time picker as well if it is not suitable. But yes, in that case, in case of asset or CMDB, we have a huge data set or result set which is being fetched. So you need to take care of having other filters configured um, correctly, so that you will be able to focus on what use case or what result you are looking for. So let me edit this. And this panel, if you look at the query, then we have not followed any best practices which we have just covered. So there is distinct added unnecessary here. Then if you look at, we have subquery here. So this is the first subquery where condition is not added. So it is pulling all the data. So naturally, it's going to take time, as you must be knowing that this AST computer system is having a huge data. And if you do not have any where condition here, it is going to take some time. Then coming to the second subquery again, we can see inner joins are also used. So if it suits your need and you can use left outer join, then always go for left outer join. And then also where condition, as I already mentioned, we need to look at adding the suitable where condition. Even in case of joins as well, whenever the two tables are getting joined, you can enhance the join criteria as well, so that the results are getting filtered at whenever the two tables are joined at that level only. And you will be able to fetch the result um, quickly, uh, as compared to um, if you don't follow this practice. Then having the limit set. So if applicable, we recommend that 50,000 is the uh, limit which you can apply, which is the best suited. But yes, you can go further as well, but uh, as and when it as per your requirement. Like we have a JDBC row limit and chunk size. These two settings are available in centralized configuration setting on Helix platform side. And you can configure those settings carefully. So if for example, you want to pull 1 lakh records, then and you have a 50,000 chunk size set, then your result so whenever you are querying uh, it to the server, then server will, on server side, it will have two API calls. First 50,000 chunk and second 50,000 chunk. So you will see in the network logs that there are two API calls which are being made to get the result of 1 lakh records. So be mindful, and if it is really needed to fetch that much amount of data, then only go for it. Otherwise, 50,000 is a good limit which you can go for. Then yeah, so I'll come if we compare this query to the second one, where I have made certain changes. So this is the same query where I have made certain modifications, like I have added where condition as per my need, which suits my requirement. So instead of this hard-coded value, you can go for the value from the variable as well, you can pass. Then I have used left outer join as it suits the requirement. Now in the second subquery, if you look at, I'm only interested in fetching the data of operating system CI, which is operating system name and OS version. So better to have that class ID defined in the filter criteria. Otherwise, it will go ahead and get the unnecessary other type of CI data as well. from base relationship. So I have added that criteria. And in this subquery again, I'm interested in getting the IP address of this particular CI, a computer system CI. So I have again added filter criteria, which is class ID equal to IP endpoint. And that way, I'm able to get the filtered result of subquery, and these results are combined to look at the final output. And if we look at the results of these queries, we can always compare here. And this took 3.73 seconds, and how much time this took. So right now it is very much, so some seconds difference I can see here, which is reduced. But when we look at the large amount of data, we get the huge difference here whenever you follow these practices. Similarly, I have example of the printers CI, which is again similar example. So here as well, there are certain criterias which were earlier not applied, and when we apply those criterias, then how the result got changed. That's what we have. So it took 2.81 seconds. Earlier it was taking 4.5 seconds. So like this, you can go ahead and follow best practices. Then let me move to the another example, which is related to incident management module in ITSM. So now sometimes what happens when so incident management, we have a day-to-day growing transactional data, and if you don't follow these best practices and trying to pull the data dump of, let's say, for last 1 year, which is very huge. So for just showcasing, I'm having this last 1 year set, but usually as a best practice, you can, whenever you are looking for a data dump report, you can go for monthly or quarterly, which is a good amount of data, and it's I mean, you can follow that particular practice. Then if you look at the original query here, so here we now along with incident details, I want to get associated knowledge articles as well. Then along with that, I want to see the audit related details for incident. Then I want to look at the assignment log information as well. And also I want to do certain calculations on those values and then display it in the dump report. Also, yeah, so you can see here that there are these 4 things which I want to fetch the data from. So this is the first subquery where I'm interested in getting the first assigned date from this assignment log. So here you need to again go for the where condition. So here we have added one where condition wherein I'm only interested in assignment type as assigned, But along with that, if I don't add any time constraint to it, so I must add time range also here. Otherwise, assignment log table, if you look at it, is very huge and it will fetch all the data with assignment type equal to assigned. So based on your domain knowledge of IT service management, it is very much required to add the uh, suitable filter criteria uh, to uh, and look at how you can filter the subquery result efficiently. So I can add here the time range to reduce the result set here. Then going to the second part of this, which is subquery, which is audit. So as you must know that audit log system is also having a huge amount of data, and from that we are trying to look at the maximum of audit date, and based on this criteria, because there are a lot of other type of logs also getting captured on the same table, and I'm only interested in assigned group. But along with this criteria, again, I can look for the date time range if I can apply here. Or yeah, then next will be the associated knowledge articles. So again, I have added here the like clause, which is only getting associated knowledge articles and nothing else, like don't uh, fetch the data related to associated CIs or any other type of request. So it will fetch only associated articles, but still there is a, uh, there is a way to further limit the data of this. You can look for that. So again, there is one more point which you can look for is uh, in the main query, we usually add where condition, and we always focus on the main query and add good filter criteria there. But same filter criteria, if you can try to add in the subquery, that will help in getting the result faster. Yeah, of course, you need to look for if that really suits. I mean, if the submitter is really available in that particular subquery, and you can look for that filter criteria or not. But yes, always take a look at main query filter criteria and try to apply it in the subquery. If you're getting timeout issues and you have a subquery in place, then yes, that's the first point you can go look at. And yes, splitting the queries and getting the results and comparing it, that also helps in identifying the root cause. So like this, again, after doing changes, so I have this fixed query with me wherein I have added, so as I mentioned, in my main query, I have this particular criteria. Also, I have time range criteria added, which is additionally filtering the data, and get with that performance is improved. So everywhere you will see the where condition is modified and improved. Yes. And you will be able to get the results in just a second. So yeah, with that, I wanted to cover the last use case, which is maybe I'll go here, which is again, I'll come back to asset dashboard. Why I'm sharing this use case with you, that it's not always just looking at the subqueries and if you'll be able to solve the problem. Most of the times, yes, you will be able to solve. But in some cases, like this particular case, so if you look at this query, this is having most of the columns are being pulled from asset base element table. And we have couple of uh, columns which are being pulled from the two different tables. Now, if you look at this inventory name, so this is being pulled from inventory storage. But to get this particular value of inventory name, I have added this two joins. So as maybe I'm not aware that inventory quality storage join uh, may not be needed, and you can directly join AST base element and inventory storage. And that's the reason I have added base element, which is joining with storage join, and storage join joining with this again inventory storage. So there are two joins which are unnecessarily added here. And so I was looking into the query and I realized that this is unnecessary. So again, here it again comes to the domain knowledge, or you can, as a part of analysis, you can analyze the data. If the required data is there in inventory storage or not, you can look at inventory storage records and are those matching with the base element. And if it is matching, then you can really go for removing this inventory quality storage join. Um, so in the second query, if you look at, I have removed this. I've commented this out, but still I'm getting the same result. And the result is quicker this time because I reduced one join. So sometimes the joins are also all joins may not be needed, and unnecessary you may have added that. Then you can try to simplify that part as well. So and lastly, I wanted to cover which is about like whenever you are joining the two tables, then your join criteria also should be on I mean, preferably it should be on the primary keys, so that the data retrieval will be faster. Uh, and you can minimize the inner joins as and when it is not needed, you can avoid inner joins. And yes, one more point I wanted to cover about admin versus non-admin scenario. So uh, mostly in some scenarios, what happens, we do not see issue with admin with the admin user, we are getting the result and we are uh, okay with the performance. But with non-admin users, we tend to see issues, sometimes timeout also, um, or slowness. So in that case, how we should tackle? Again, same approach or same best practices you can follow. But main difference between the database queries which are getting formed between if you compare admin versus non-admin database query, which is getting actually executed on server layer. Admin, uh, you don't have any row level security in picture. But for non-admin, user, row level security clause gets applied uh, and gets appended at the end of the database query, which actually gets executed on database. So for non-admin user, if the issue is happening only with non-admin user, you can look from that perspective as well, that if my row level security algorithm on platform side is correctly configured, or do I need to look for some other RLS algorithm? All those aspects we need to look at if you are only seeing the issue with non-admin. After following these best practices, also, if you don't see any change, then we can look for RLS algorithm and those details on the platform side. Yeah, so with that, I'll come back here and we will just summarize what we did in the part 2 today's session. Uh, First, we looked at the efficient process of dashboard development. Then how to streamline your query design by following certain approaches that we looked at. Then how to design optimal queries, that also we have covered. And lastly, how to troubleshoot timeout queries. That part also we have covered. With that, there are some references which we'll be sharing here, and you will find these details in the presentation on how to use row limit configuration, then how to use calculated fields, how to optimize query performance. Here you will see certain areas of optimization. Then we have some frequently asked questions over here covered, and the troubleshooting part is also there as a part of reference. With that, we can go ahead for Q&A. Thanks to all of you for attending this session, and with that, I'll hand over to Sam
Thank you,
for Q&A.
Kashita. So the team have been very busy answering a lot of questions during the session. I know that we've still got one that's open at the moment from James. So James, I have given you access to be able to speak with us live as well if you want to. But his question to the rest of the team was, where can we see what the primary keys are for every table? So I don't know who wants to take that from the team.
We can share with you the entity relationship diagram for ITSM, and that should be sufficient. It shows the primary key, foreign key relationships among the various forms in ITSM, if that's what you mean.
Does that mean, sorry, does that mean that it will show every table, or just the main ones that you deem as the main tables? Does it show every primary key, or just the main ones?
It shows the main ones.
Is there any way, like we have like custom fields, for example, potentially custom tables? Is there anywhere that shows the primary keys from every table?
No, so this is a static, so it's a static document that we'll share with you. But for your custom fields, your custom forms, you will need, you know what customizations you have done. There's no way to generate that from the system. We have a static document that we can share with you about the ITSM ERD.
I think we've received a document with some primary keys, but I don't know if some of the field, was it a PDF you're referring to?
Yes, it's called
Yeah.
ITSM ERD, ITSM-ERD.pdf.
Oh yeah, we've already received that. I wondered if there was any other links to anything else which would be showing primary keys and how to do joins, like inner joins, outer joins, left joins, things like that. If there was anything like that anywhere as well.
And no, that's about all we've got.
Okay, thanks.
Thank you, James. Next question was from Eric. So Eric's question was regarding the RLS topic. Are there queries executed as the current logged in user? If so, is there a way to provide dashboards that are executed as reporting service account that may not be restricted to the user's RLS? And Eric, feel free to come off mute.
I can go ahead for this. Yeah. Regarding RLS, if you look at, yes, currently the queries are getting executed with currently logged in user. And that's the reason RLS is getting applied as per user access.
Got it. Okay, yeah, I was curious because that was a point that you made that I did not realize, and it does make sense. But a lot of our reports, I was just wondering if it was possible to develop the dashboards under like a service account that, to your point, would have that admin and may give a more efficient query because it's not having to factor in the row level security.
Yeah, definitely. I mean, if you, while designing dashboard, if you go ahead and use admin account, which is available, then yes, your queries will be faster and you will not have RLS clause applied with that user. But yes, you will not see restricted data. You will see all the data. And sometimes the need is to see only restricted data based
Sure.
on the. Yeah.
Okay. Yep, that makes sense. Thank you.
Thank you for the question, Eric. Zoya, if you want to come off of mute as well, I can see you've put a question into the Q&A around limitations when using distinct and suggesting that in some cases you get an error message that you want to convert some values and there is no convert command in SQL. So I don't know if you want to elaborate and who from our team want to answer that question.
I can't add any more hello at first. Yes, in some cases we'd like to use distinct to limit the values which we have in our query. And when we use it, we have an error message that that I want to convert something from varchar to date int, and there are no such command in my SQL query. So I don't want to convert anything. I want really to have varchar, integer, and varchar value, also columns. And I have this, and I can't use this thing.
Okay. So do you aware, do you know which database the ITSM is deployed on? I mean,
Microsoft SQL.
okay. So I think we need to look at from that perspective that if the MS SQL is giving that particular error.
Interesting, when I
or-
try to write this SQL exactly in database, I can use this thing, but when I try to do it in Helix dashboard, I can't.
Okay. I think we need to look at the particular use case.
Okay.
Maybe, yeah.
But you don't have any limitations to use distinct.
Yeah, don't have any.
Okay. Thank you.
Thanks.
Thank you, Zoya, for your question. Okay, we've got a couple of other questions. So, oh, no, it's been answered. Apologies. Monoj, do you want to come off mute? I can see you've raised your hand to ask a question. Can you hear us? Monoj? Do you want to try and unmute again?
Yeah.
Hello? Hello.
Yeah. So I have a question around using dashboard as a data source. Like, let's say I have created a panel, but to represent the same data using different plugins, I use one of the dashboard panel as my data source. Is there any limitations like how many such panels we can create? What I have observed, if I create anything more than 3 panels, referring to any query, right? That's already running, and then probably the data is not getting loaded correctly. At times there is no data, but other than that, it works fine. So I wonder if there is any limitations around that.
So you wanted to say like you have created 3 queries, let's say, and those 3 queries you are using as a data source, right?
No, I have a query. Let's say it's a tabular format data,
Okay.
right? Now I've used different other plugins like bar
Mhm.
chart, pie
Yes.
chart, things of that nature, referring to the original one, which is the
Okay.
tabular format data.
Yes.
So when I create anything more than 3 panels referring to the
Okay.
actual query,
Mhm.
this is where I observe at times the data for those panels referring to the
Mhm.
tabular format is not getting loaded. And this
Okay.
I have observed in the latest version if the number of panel count increases to anything beyond 3.
I mean, if I want to answer this question, there is no limit at present, but in your query, which you are using it as a data source, have you put any filter criteria there, or it is just giving the whole dump, or how it is?
No, I mean the filter criteria are already appropriate,
Okay.
including where clause, the date criteria.
Okay. I think we need
Okay.
to look for,
If
but yes, there is no
okay,
limitation.
okay, all right. Yeah, thank you.
Okay, we don't have any other questions in the Q&A. Does anybody else have any that they would like to ask? Raise your hand or come off mute.
Yeah, thank you for the presentation. I have a question. Could you share the SQL from Keshita she have presented before? Would be very helpful.
Sure. Yeah. The one with subquery?
Yes, this one with subquery. Was very interesting. Good queries.
Okay. Yeah.
Thank you.
Okay. Anybody else? Okay,
Is
so
there
we've got
any
a-
document available currently to relate, I mean, real use case wise, where to use, let's say, single code, BMC single code, person code, things of that nature?
Regarding BMC single quote, we have added it in frequently asked question section that I can share it with you. Alicia, you have any article around it? Do you know?
Not handy, but I can
Yeah.
take a look.
Sure. Yeah. We can share, I
So the
think.
reason behind, so the
Mhm.
reason behind this question is most
Mhm.
frequently I'm working with LATAM customers where we are having challenges related to non-English
Right.
strings, and at that point in time, uh, the use of single code, BMC single code or person, these escaping
Mm.
are being used very widely. At this point in time, it's all trial and error
Mm.
basis I'm doing. I'm not sure if there is any internal, at least, knowledge base or any document that we have that list out all the possible ways of referring to these variables and which variable suited most for what sort of data. With an example, if that's something available, then I think it's going to help a lot.
Yeah, we have taken your feedback, I think, and we, if we don't have it in detail, then sure, we can go ahead and publish that as a part of documentation.
Yeah, thank you.
Thanks.
Thanks, Manoj. Okay, I did see another hand raised. I think it was Gavin, but he's taken his hand down. So if you haven't got a question, Gavin, I'll assume you're okay. Unless you want to speak, I can see you've come off mute. Can you hear us? I think you might have audio issues. We can't hear you. Gavin, if you do have a question, you want to follow up with us directly, just if you want to email me, I can speak to the team. We can't hear anything from you. You look like you don't have any audio aligned. I can see you've raised your hand. Do you want to try and come off mute again? It may be that you've joined via the browser rather than the client of Zoom. I know often that can mean that you don't get the audio capabilities working properly, from what I've heard. So we can't hear anything from you. Yeah, maybe drop an email or put it into the Q&A. There is another question, team, just in the Q&A saying, does BMC have any documentation on key queries and best practices for specific scenarios, for example, work orders linked to tasks and audit logs?
The ITSM entity relationship diagram that I mentioned should help. What you need to know is how to relate work orders to tasks and audit logs. Yes, that should explain. That document should explain it.